finding the surface area of prisms on tonight's homework. I'm going to do problem number 3 with you. There are only 5 problems. That's because each one takes a bit of work, especially when you're first starting to learn how to do this. And I'd like us to do it the right way, which means showing your work. So I'm going to show you what I mean by that with this first example. This is obviously a triangular prism. There are parallel congruent triangular bases. So I'll call those triangles, let me get a better color here. I'll call those triangular faces A. And there are 2 of them, but I only need to do one of them, the area of one of them, and then I'll just note to double that. So you really should sketch your faces. I have this triangular face. It has a base of 15 and a height of, it's not good, height of 12. And base and height are all I need to calculate the area of that face. The area of face A will be 1/2 base times height. So the area of face A will be 1/2 multiplied by 15 multiplied by 12. I'm going to associate and take half of 12, so 6 times 15 is 90. So the area of face A is 90. Now I know there are 2 of them, but we'll account for that when we read our surface area formula. First I want to identify each of the faces, each of the different faces, and sketch them. I'll call face B the bottom, this bottom face. You can sort of see this would be a rectangle, a 20 by 15 rectangle. And so face B, I'll sketch that here, is a rectangle with a base of 15 and a height of 20 if we're sketching it this way. You don't need to, for rectangles, you don't need to show a formula. You just know it's base times height. 20 times 15 is 300. So the area of B is 300. We have these 2 triangular, or sorry, not triangular. We have these 2 faces that are part of this. They're slanted, is what I'm trying to say. It's hard to point to a face when the object is see-through, but hopefully you know. I know what to do. I'll just highlight. Let me highlight this face. You know what I'm talking about. I'm talking about this face right here. Is also rectangular, but with different dimensions than that bottom face, slightly different. It still has a height of 20, but the base is 14.2. There's also another face over here that's even harder to see. This face. Since there's no dimension given here, you can assume that this is also 14.2. This looks like an isosceles triangle, so if they don't give you the dimensions, you can make that assumption. And so that's another 14.2 by 20. So really there are 2 faces that look like this. There are 2 of these faces that I'm going to label C. And they have a height of 20 still, but a base of 14.2. This is pretty easy to do mentally also. You just double 14.2, you get 28.4. Then move your decimal 1 to the right to multiply by 10. So 284 would be the area of face C. Once you've found the area of all the different faces, you just need to construct a surface area formula. It will be different. It just depends on what you're looking at. For this particular triangular prism, the surface area would be equal to 2 multiplied by the area of face A, because we know we have 2 of these congruent triangular bases, plus the area of face B, because this bottom face is the only rectangular face with these particular dimensions, plus 2 multiplied by the area of face C, because this face is the same as congruent to this face back here. then you just substitute your areas and then calculate the total surface area. Do that during the pause, and then take a look at number 5, because that's what we're going to look at next. Do all that during the pause and come back, please.
Paused.
So just substituting in the areas that we've already calculated, 2 multiplied by the area of face A is 90, so 2 multiplied by 90 plus the area of face B is 300, plus 2 multiplied by the area of face C, which we determined is 284. So 2 90s is 180 plus 300 plus 568. 480 and 568 is 1048. And these units are inches, so inches squared. Not cubed. You might think it should be cubed because it's a 3-dimensional object, but remember, we're finding surface area. Surface area is literally the sum of the areas of all the surface faces. And so I'm just double checking my math there on the, that's right, 1048. Okay, I want to look at number 5 with you briefly. I don't want to do the whole thing for you because I want you to be able to think about it yourself, but if we call this, first of all, we're finding the total surface area of the hollow concrete casing shown, including the interior surface. That's what makes this one tricky, including the interior surfaces. So pretend this is typical concrete looking thing, so kind of probably gray. Maybe it's like a gray concrete. And then you pretend, just to help you visualize what surface area means, pretend I dip it in blue paint. Obviously this this face will get blue paint on it, this face will get blue paint on it, this will get blue paint, but also there'll be blue paint in the interior of this hollowed out section. So you have to take that into account when you're finding your surface areas. If we call this the front, and I call this face A, A is a 12 by 8 inch face. And you see that this is 8 inches and so is this. So face A is repeated all the way around the figure. The top, the bottom, the front, and the back are all this same rectangular face. So you'll know what to do with that. If that's front, this is side. The side face looks like a square. Wasn't very good. It looks like an 8 by 8 inch square, but then there's a square cut out of it. Which has dimensions 4 by 4 inches. So you're trying to find, for the surface area of that face, you're trying to find this area. And we've done problems like that before, so you'll remember what to do there. Then let's just call that face B. Just recognize that there's another congruent face just like that on the other side. Then you have rectangles on the inside, 4 congruent rectangles on the interior of this hollow casing. I'm not going to draw those. You figure that out on your own, but those are 4 more faces that you'll need to find in order to find the total surface area. It's a tricky problem, but there are a lot of congruent faces, so you really only need to calculate the area of 3 different shapes and then come up with the right surface area formula. So I hope that helped get you started on that one. I'll see you tomorrow.